Good morning, everybody, and welcome back for another Friday Facebook Live. This is Taylor. I'm Nick, and we are coming to you live from the New England Aquarium right in front of our lovely Indo Pacific Reef Community exhibit. This is actually the, you could say, the newest exhibit here at the aquarium in terms of the fact that it was the most recently renovated exhibit. It's a beautiful place to learn more about what it's like to experience life on a coral reef. And there's a reason we're standing in front of this tank that we'll actually reference a little bit later during the presentation. Since we have another themed Aquarium After Dark night happening tonight, yes, that's right, our hours extend on Fridays till 8 p.m. We figured that we would talk to you guys a little bit more about what tonight's theme is going to be in order to prepare you, but also for those of you guys that aren't able to attend, just to give you some more fun information, give you a chance to learn. It's always good to learn, right,
it's always
Taylor?
Good. Absolutely.
It is. Yeah. So tonight's theme is one that you might not have, or you might have heard about before, but not necessarily acknowledged, and that is ecosystem sounds. So our world, both above and below the ocean surface, is actually a pretty noisy place when you kind of stop to take a listen. It's full of sounds that can tell us a lot about what's happening. Tonight's attendees are going to learn more about that and also get a chance to experience some of those sounds playing from speakers in the building that represent different ocean habitats and what's happening in those places. You'll also learn more about the categories of sound as well. But in preparation, again, Taylor and I thought that we would talk a little bit more about this topic and give you a particular example as well. So perk up those ears. Hope you guys are ready. Taylor, take us away.
Alrighty. So while you might take sound for granted, it does play a really big role in our world. Now, scientists typically categorize sounds in the natural world into three major chunks. There is geophysical, biological, and human-produced sounds. Now, geophysical might sound a little complicated, but this actually just refers to sounds that happen within a natural environment. Think things like wind and rainfall, thunder, waves crashing, so sounds produced from the natural environment. Biological sounds refer to sounds being made by living organisms within that environment. Think our very noisy rockhopper penguins who you might be hearing in the background of this presentation this morning. And then human-produced sounds, that one you could probably guess at, but if you're looking for a few examples of a human-produced sound, just take a walk through a big city like our own city of Boston, and you're sure to hear some human-produced sounds. Now, you would probably expect to hear mostly geophysical and biological sounds in an ecosystem, and that combination is actually usually a good indication of a thriving and healthy ecosystem. But we also have the introduction of some human-produced sounds, and that can have a specific impact on the ecosystems that we will talk a little bit about later. So, animals looking to reproduce might create sounds that will help them locate a mate. They might create sounds that help them find prey. They could use sounds from the natural environment to find a good home. And once they find that good home, use sounds within that environment to either ward off invaders, protect their territory, protect themselves from predators, and to do a number of other various behaviors within that environment. So sounds are actually really, really important for animals' natural behavior and the way that they interact within their home, within their ecosystems. And so we thought to help illustrate this a little bit, we would give you a specific example today to kind of illustrate the importance of sound in an ecosystem. So Nick, would you like to tell us a little bit more about that specific example we're going to talk about today?
I think we've tried to tease it a little bit, Taylor, but
Okay.
I bet you guys can guess what
Just
we're
maybe,
talking
yeah.
about here, right? Yeah, we're talking about coral reef habitats. So before we get specifically to our Indo Pacific reef here and reefs in general, we'll just talk about the oceans as noisy places, because it turns out that oceans are very noisy places. And this is in part because of the fact that sound actually travels faster through water, and it keeps its energy for longer as well. So the sounds will perpetuate longer underwater. We'll save the details of all of this for another Facebook Live. We'll also have to call in a sound expert, I think, to properly describe all of this. For now, you'll have to take our word for it. But within the ocean, healthy reefs are actually one of the noisiest ecosystems that exist. In fact, observers often will compare the sounds on healthy reefs to what you might experience in the middle of a healthy rainforest. Contributors to this soundscape include snapping shrimp, which produce little air bubbles that actually pop and make a sound that sounds a little bit like frying bacon. I learned a little bit about this from Taylor. Some fish which produce grunting sounds with their swim bladders to mark their territories. And other fish which might create grinding sounds while they're chomping away on algae or on the hard coral skeleton itself in order to get food. This doesn't even include marine mammals, which might be visiting the area in a reef that are producing things like clicks and moans to either locate food or members of their pods. Reef sounds are so significant that scientists have actually begun studying them in terms of how distinct each reef sounds, as well as how sound compares to reef health. So, if it's a louder or a particular type of sound, does this mean that the reef is healthy or not so healthy? In general, studies have shown that a healthy reef is actually a pretty noisy one, with many of the diverse sound examples existing that we just mentioned, some of the examples that we just mentioned. Even more interesting is that studies have shown that each reef might have a unique soundscape, a unique signature sound, and that both fish and coral larvae as well can decide where to live based on finding the ideal soundscape. Sometimes that even matches the reef where they were born, which is really cool. And then taking this a step further, scientists are investigating using sounds of healthy reefs to actually attract fish and corals to unhealthy reefs with the hope of rebuilding struggling reef communities, which is pretty amazing.
I think that is pretty darn cool. So using sound to help repair coral reefs.
Right?
Who knew?
Yeah.
Now, there are some sounds within a particular soundscape that can be negative or destructive. And unfortunately, all of the sounds that fall into that particular category are man-made sounds. Now, in a marine environment, this typically includes things like marine construction, shipping, use of sonar, seismic testing. A lot of these things that might sound familiar to you are things that have come up in the news as issues of concern when considering human activities in the marine environment. And unfortunately, with increased frequency and increased intensity of these sounds, they can negatively impact animal behaviors, things that we just discussed. So for example, this might prevent animals from finding an important nesting site or an important foraging place, might prevent them from finding mates, which can negatively impact reproduction and overall populations, and in some cases can even mask communication between individuals. This is a particular concern with marine mammals. Sure. If you think about dolphins and whales that really heavily rely on clicks and chirps and squeaks for that communication. The good news is because we understand that this is a human-made problem, we need to then further study the impacts and the intensity of this activity so that we can help mitigate the impact of that sound. And I think actually some of our scientists here at the Anderson Cabot Center for Ocean Life are already involved in doing some of this work, which is pretty cool. And I think you'll learn a little bit more about that on our Blue Planet Science series next month.
Ooh, yeah.
Something to look forward
Another
to.
teaser. Yeah.
Yes. So that is a little bit about sounds in the ocean, sounds under the sea. And I think at this point, what we will do is we will open up the floor to questions from all of you to see if you have anything that you're curious about around this topic that hopefully Nick and I can answer. Remember, put those in the comments so our lovely camera woman, Marissa, can read them for us.
Question. I don't see their ears.
How do fish hear sounds?
Such a good question. Such a good question. I'll start with this one, Taylor, and you can help me out. So believe it or not, fish actually have similar inner ear structures to us. It's just that their outer ear structures don't look like our outer ear structures. And you know, technically, if you want to get into it, we evolved from animals related to fish. But that we'll save that for another Facebook Live.
Yeah, technically you're all fish. Go figure. But
isn't that amazing, right? So I was reading about this morning just to make sure I get my details right. I knew a little bit about it, Taylor, and I know that you do as well. But I wanted to really get this correct. Basically, what is happening inside the structure of a fish's hearing is there's an area where there's a little bone that's called an otolith, which is a dense bone that, again, sort of resembles some of the bones that we have in our inner ear. And that bone is floating around basically in a fluid-filled area that also has little hairs sticking out, sort of connecting with that ear bone, that otolith. And when sound is produced in the water, it will cause that otolith to vibrate, and then those little hairs that are sort of touching that otolith will respond to that vibration, and it's able to give the fish information about where the sound is coming from, how intense it is, whether it might resemble a sound that the fish is familiar with, such as the grunt of a fellow species member, or the animal that a predator might make, or the sound that a healthy coral reef makes as well. So it's pretty amazing. And another really cool thing I think about otoliths, those ear bones that fish have, scientists use them to age fish as well, because the way those bones grow, there are little rings that are produced. And each ring, just like the rings inside of a tree trunk, indicates a certain range of time. So scientists can use them to make an estimate of how old a fish is.
So I think the important thing to remember about ear structure is that it is also an adaptation. We talk about adaptations a lot, right? And Nick mentioned earlier in our presentation that sound travels through water at a much greater rate, much more easily than it does through air. So our ears are designed for funneling sound coming through the air, but fish's ears are perfectly designed for sound coming through the water. Again, adapted to where they're living. Great question.
Do you know what the loudest sea creature is?
The loudest sea creature. That's a really good question. You know, off the top of my head, I'm not 100% sure. My guess would probably be some sort of cetacean, so whale or dolphin. They can produce sounds that if you're in the water with them, you can hear from like miles away. It's pretty incredible stuff. And I've been told, I've never been in the water when whales are singing, but I've heard it kind of like vibrates through your whole body, which is pretty awesome.
I have been able to experience
Have
this
you?
underwater, Taylor, and it's pretty awesome. Yeah.
Would that be your guess as well, Nick?
Yeah.
Some sort of cetacean is probably the loudest
I think you're
animal
right.
in the ocean.
And if you think about how they move around, how they have to sometimes travel really long distances, and they may be separated from other members of their species, being able to produce a very large booming sound that's going to travel very far underwater is a real asset for them to be able to survive, exist within their social structure, connect with mates, potential mates, things like that, right? So they would need to produce a pretty loud sound. So I'd go with something like that, yeah, for sure.
This kind of answers the next question. Can humans hear the sounds underwater?
Can humans hear fish sounds underwater? Nick, you've told me stories about this before. Would you like to share with our viewers
Sure.
this morning?
Yeah, no,
Yeah.
Well, I was actually going to connect to what you just said too, Taylor, which is that while marine animals are very adapted to be able to sense and hear sound underwater, humans not so much. So we're not hearing things in quite the same way or at the same frequency or volume that maybe animals living in the ocean are, but we can still hear things underwater for sure. And I think I've talked about in a previous Facebook Live right in front of this tank about how being a scuba diver and descending onto a coral reef as you're getting closer and closer, all those noises that we've been talking about, the pops, the clicks, the crunches, all those crazy sounds, the volume starts to turn up. And as you get closer and closer to the reef, you're just surrounded by this cacophony of noise that you don't even really think about. And as you look around, it's sort of hard to realize that there are all these things present on a reef that are making these individual noises, and all together you're getting this chorus of sounds. And so it is definitely possible to hear noises underwater, and they are unique and interesting, and they can tell us, again, a lot about the health of a place like we've been talking about. But going back to what Taylor was just talking about, just not quite at the same level as the animals that live in the ocean are hearing things. So, yeah. Would you add anything to that?
No, I think you nailed it, Nick.
Okay.
What kind of clam is that?
What kind of clam?
Very good.
So this is an artificial clam, but what it is representing is a giant clam, which is a Pacific species of clam that can grow to be bigger than me. So in fact, this would be a juvenile giant clam. And speaking of juvenile giant clams, we also have some living juvenile giant clams just at the end of this hallway in our living coral reef exhibit. And those guys are really tiny because it takes them quite a long time to get tailor-sized. But that is what you're looking at there. And I think one of the really interesting characteristics of this clam is that bright coloration that you're seeing around the opening. And that is actually something that it shares with coral. There is a symbiotic algae that lives underneath the kind of the skin membrane of this clam that also helps produce energy in the same way that corals get energy from the sun. So there you go, a little clam facts in the middle of our
little clam
sound
facts for you.
ecosystem presentation this morning.
So you said sounds influence where corals settle. Can planktonic corals actually direct where they go to settle, and how do we know sounds influence them?
Can tiny corals direct? Is that what the
Yeah,
question
can
was?
they
Direct
decide where they would like to settle if they're planktonic?
Yeah. So I was also reading about this morning. I know that you and I like to show off that we start our Fridays by reading these really heavy research papers, try to prepare for our Facebook Lives. So I can talk a little bit about this. And the reason I started reading about it actually was because Taylor had done a little research about this related to fish and fish deciding to settle on reefs. And I thought, I wonder if it's the same for corals as well. And it sounds like it might be, but it's still something that scientists are learning about. There have been some confirmed studies that indicate that reef fish can actually settle on a particular reef because they are, or by recognizing the fact that it sounds healthy, it sounds like where they may have come from. And studies have actually proven this. They've shown that reefs that produce healthy sounds actually tend to attract more fish and sometimes more higher diversity of fish as well compared to other reefs. We could go into like larval development of fishes, but that is definitely a great topic for another Facebook Live. They're basically, they hatch from an egg, they kind of go away, and then they come back to their reef to settle in very general terms. And so sounds may cause them to attract to a particular place. Now, larval fish, it turns out, even though they're really small, they are actually pretty mobile. And there's been some testing by putting larval fish like in a flume and sort of directing water towards them. And these little larval fish can actually swim against that current. So they are fairly mobile, maybe more mobile than we realized. So there's a little bit more intention behind them being able to find a home that sounds like a healthy place, sounds like a healthy reef. In the case of coral larvae, what I read this morning, Taylor, was that they indeed have shown evidence that they may settle on places that sound a little bit more healthy. Unlike fish species, coral larvae do not have like a centralized nervous system, and so they may be responding at like a little bit of a different level than, say, a larval fish, but they certainly have shown evidence that sound may play a role in them deciding where they end up settling down and starting to build their hard coral skeleton and growing and living. So there may be a little bit more intention there than we realized as well. It's still something that's really being studied, but pretty cool.
The other thing to keep in mind is sound is just one factor that influences this decision. Animals are so in tune to things in their environment and things that humans can't even perceive. Like in some cases, animals can literally taste the chemical composition of the water and use that to make decisions about like where to go or where to find food or where's a good mating site. So I think there's a lot of factors that we don't always think about. So it's important to keep in mind that sound is just one factor, and scientists, when they do studies, often have to kind of break down which of these factors is kind of like the biggest influencer. So there might be some other things that we just don't even know about yet. But they have confirmed that sound definitely plays a role.
Really talking my language here, Theo. This is really, I love this stuff.
Yeah, these are great questions. Do we have any other questions out there?
Do the fish hear the sound of the filters running, and does it affect them?
Do the fish hear the sounds of the filters, and does it affect them? They absolutely can hear the sounds of the filtration. And whether or not it affects them, I couldn't say for sure. It doesn't seem to have any negative impact on their natural behavior. We still see them doing all of the normal things that we would hope and expect, resting, feeding, mating, territory guarding, the whole kind of gambit. But they certainly can hear the filtration, and actually if you've ever been behind the scenes or if you watch one of our videos where we're standing behind the scenes, the filtration's actually pretty loud. But again, I wonder if this has any correlation with anthropogenic sounds in the ocean and their ability to adapt and overcome and their environment here at an aquarium.
Yeah. Good question too. Yeah. Any other questions? We've had some good questions today. Yeah, so if you guys do have any other questions that you think up, remember, don't forget to put those in the comment section on our Facebook page, and we'll continue to answer those as best we can. Should we wrap things up, Taylor?
Let's wrap it up.
Okay, as you guys hear some of our other animals here at the aquarium making sounds as they wake up, like Taylor was mentioning, our rockhopper penguins making some sounds. We want to thank you guys for tuning in and learning a little bit more about sound above, but particularly below the ocean surface. And we hope that you'll pay a little bit more attention to sounds when you walk out of your front door and go for a walk or even go for a swim underwater. For those of you guys that are visiting the aquarium tonight, again, you're going to learn a little bit more about this. You'll get to experience some of the sounds that marine animals experience in their world in some of the different gallery areas that we have here. And then I think also this is a good time to remind everybody again as we approach November 3rd, voting day, right? Don't forget to use your citizen power to support and visit places where human activities are already being restricted, such as national parks or marine sanctuaries, because these areas actually provide respite for the animals from man-made sounds. They're also great places for you to experience what a healthy ecosystem sounds like with all those geophysical and biological sounds sort of permeating the whole entire area. Thank you guys again for tuning in. Stay tuned for future Facebook Lives and more fun and more learning and more virtual content coming your way. Have a great Friday and a great rest of your weekend.
Bye, friends.